Students, now we will discuss about remain standard forms. In the previous lecture, I explained limit extending to 0 sin x by x is 1, where x is measured in radians. Same way I explained as limit extending to 0 tan x by x also 1 I explained, right? Okay, now limit extending to 0 sin inverse x by x is 1. Sin inverse x by x is 1. Limit extending to 0 tan inverse x by x is also 1. How you got this one? See this. Limit extending to 0. See here, sin inverse x differentiation is 1 by under root of 1 minus x square. And denominator differentiation, x differentiation is 1. Now you substitute the limit in this. I get 1 upon under root of 1 minus 0 square divided by 1. It means I get 1 by 1, that is 1. So that's why limit extending to 0 sin inverse by x is 1 is the right answer. Next, another one, limit extending to 0 tan inverse x by x is 1. How you can write this one? Limit extending to 0 tan inverse x differentiation is 1 by 1 plus x square divided by differentiation of x is 1. Differentiation of x is 1. Now you substitute the limit 1 by 1 plus 0 square divided by 1, that is 1 by 1, that is equal to 1. So the answer is 1 for this standard limit. Now another one, you have limit extending to 0. Now see here. See, if you don't know formulas, I wrote here. You can check these formulas once. So those who don't know the formulas, you can see the formulas first. D by dx of sin x is cos x. D by dx of cos sin x is what? Cos x. D by dx of cos x is what? Minus sin x. D by dx of tan x is sec square x. See, this proof you will get in this chapter only. Wait till the end of the chapter. Means when I start differentiability, continuity and differentiability in the topic, you will get d by dx of cosec x is minus cosec x into cot x. D by dx of sec x is equal to sec x into tan x. D by dx of cot x, that is minus cosec square x. D by dx of log x is 1 by x. D by dx of a power x is a power x log a. D by dx of e power x is e power x. See here, this part you are not able to see because lighting is falling on that. So d by dx of e power x is equal to e power x. D by dx of x is 1. Okay, remember these things. Now let's see, limit extending to 0 e power x minus 1 by x is 1. This is another standard. You have to remember these formulas at any cost, all these formulas, all these standard limits. So I can write as limit extending to 0. So e power x differentiation is what? E power x minus 1 differentiation is 0. X differentiation is 1. Substitute the limit, I get e power 1, e power 0, x is 0, na? E power 0 minus 0 by 1, e power 0 is 1, 1 by 1 is 1. So I got e power x minus 1 by x is 1. So here this is the proof done. Now this one, proof, see this one, limit extending is 0, log 1 plus x divided by x is equal to 1. Now what I can write here, limit extending to 0, I know that log x differentiation is 1 by x. So 1 by 1 plus x you have. Log x is there means 1 by x. Log 1 plus x means 1 by 1 plus x. Divided by x differentiation is 1. Now substitute the limit here, 1 by 1 plus 0 divided by 1, that is equal to 1. So this proof also done. This is also done. Now another one is what? A power x. Now you know that limit extending to 0, a power x differentiation of a power x is a power x log a. See, base e we can write, we don't write, it's okay, fine. Minus 1 differentiation is 0 divided by x differentiation is 1. Now substitute the limit, a power 0 into log a with base e minus 0 is 0 only divided by 1. See, a power 0 value is what? A power 0 is 1. So what I got? Log a with base e. So I got as what? Log a with base e. So I got limit extending to 0 a power x minus 1 by x is log a with base e. These are the all standard limits. So you have learned all the standard limits Now I hope you have understood all the standard limits. See, differentiation, about differentiation I will explain in the next chapter, but till that time you have to remember, already you have learned in the physics. Okay, so sometime I explained in the some other topics also. What have you learned now? Limit extending to 0, sin x by x is equal to 1. Limit extending to 0, tan x by x is equal to 1. Limit extending to 0, sin inverse x by x is equal to 1. Limit extending to 0, tan inverse x by x is equal to 1. Limit extending to 0, e power x minus 1 by x is equal to how much? Limit extending to 0, e power x minus 1 by x is equal to how much? 1. So these are the things you have learned. Next, what you will learn? Limit extending to 0, a power x minus 1 by x is equal to log a with base e you will learn. Correct? And limit extending to 0, what till you have learned? How much? What other things you have learned? Ln 1 plus x by x is equal to 1 you have learned. So these are the standard limits you have learned. Correct? Whenever you have limit extending to 0, sin x by x is 1, then similarly limit extending to 0, sin 2x by 2x also 1. Reason is what? If x is tending to 0, then 2x also tending to 0. So one thing remember, you have here x, you have here x, you have here x. So limit extending to 0, sin x by x is 1. So limit extending to 0, sin 2x by 2. If x is tending to 0, 2x also tending to 0. Sin 2x by 2x is, so that is also 1. Suppose you have any time like this, limit extending to 0, you want to find sin 2x by 2. Sin 2x by x. What is this limit? Then what I do here, I will convert into such form, limit extending to 0, I will write here sin 2x divided by, I will multiply with 2 and I divide by 2. I multiplied with 2, divide by 2. Then here, if x is tending to 0, 2x also tending to 0, and this value will become 1. So I get as 1 into 2 is equal to 2. Remember this formula will applicable for all the standard limits. So this method is applicable for all the standard limits. You should learn this thing carefully. Now one more thing I want to explain, very important thing in this, that limit extending to 0, I just want to explain, this is a very important one for JEE. Limit extending to 0, greatest integer of sin x by x is how much? Limit extending to 0, greatest integer of x by sin x is how much? So these are very big question marks. Limit extending to 0, tan greatest integer of tan x by x is equal to how much? And limit extending to 0, x by tan x, greatest integer x is equal to how much? So here the question mark is greatest integer. These are greatest integer. Okay, this is a greatest integer function. It's acting here as greatest integer function, not as box. Okay, I think the first one not able to see. I'll write again. Here limit extending to 0, limit extending to 0, greatest integer of sin x by x is how much? So these are the question marks I need to explain you. See this is the graph. You need to understand these things by using the graphs. Am I right? I'll explain now in the next video. Wait and see.